Yes.
Okay. Good morning, good afternoon, and good evening. Welcome to the World River and Delta System Source to Sink webinar series. This webinar is co-sponsored by U.S. National Science Foundation, North Carolina State University, Louisiana State University, State K Lab of Estuarian Coast at the East China Normal University, as well as Utrecht University. So today it's my honor to introduce our speaker, Dr. Zhifei Liu. The title of his talk is Source to Sink Transport Processes of Fluvial Sediment in the South China Sea. So before I introduce Dr. Liu, I want to give you a few quick reminders. So as you probably already know, all the Source to Sink talks have been archived on YouTube channel, and they are free and open to the public. You can feel free to watch those videos online. We also have a Twitter account called Source to Sink. You can follow us on seminar announcements. Next week, there will be a seminar by Dr. Paul Seal from France. The title of his talk is How do tropical cyclones directly generate turbulent currents offshore small river deltas? Insight from numerical models of Mindoro Island Delta, Philippines. And just to remind you, the time will be US Eastern Time, 9 a.m. And I believe, Paul, this will be Beijing time at 10 p.m., right?
That's right. This is a typo. I'm sorry.
Yeah.
Same time like today.
Yeah. So because the daylight saving time in United States was over last week, so now we have slightly different hours. So it will be US Eastern Time 9 a.m., but this will be Beijing time 10 p.m. Okay, just like today's seminar. Okay, now let me introduce Dr. Liu. Dr. Liu is a professor of sedimentology from the State K Lab of Marine Geology at Tongji University. He received a BS, MS, and a PhD from Chengdu University of Technology. He did a postdoc at France and Tongji University, after which he was promoted to associate professor, then the full professor at Tongji University. Dr. Zhifei Liu's research is mainly focused on the study of deep sea sedimentology and a combination of land seas of heterogeneous clastic sediment through in situ observation of mooring system and lab analysis of sediment. His research interests include the source to sink transport processes, in situ observation of sediment dynamics, deep sea sediment, East Asian monsoon, and tectonic uplift of Tibet Plateau, and basin evolution in South China Sea. So now I'm going to stop my sharing, and Dr. Liu, you can go ahead and share your screen.
So thank you, Kevin, and thank you, Paul, for inviting me to give a talk at this the wonderful, fantastic time series of the Source to Sink webinar talks. So as Kevin said, so my name is Zhifei Liu from Tongji University. So my major work in recent 10 or 20 years focusing South China Sea, Source to Sink transport. So today, I would like to present a short summary and the progress and prospects of my study. So as you see here, we have in recent years many collaborators. So I group them, my colleagues and students from Tongji University, and our scientists, colleagues from the countries surrounding South China Sea, Southeastern Asia countries, and some collaborators from the France and Germany and Switzerland. So I not give them in order, but just group them. So this is actually the group work for the South Sink transport processes. So as you know, when we see the South Sink from mountains and then go through the river flat and then to the deep sea. So it's controlled actually by the tectonics, the climate and sea level, and also transport in the mechanism, dynamic mechanism in the deep sea. So in the view of the world South Sink, we can see the amount of huge river sediments discharged to the oceans. And if you think this big area, about 70% of the total global discharge in Southeast countries. And the South China Sea is located in the middle. Because the South China Sea provides a lot of sediment from the rivers, including the world's largest rivers, like Pearl River, Red River, and the Mekong, and many rivers, small rivers around the South China Sea. And more important, these rivers provide a huge sediments. So if you account the measured or model sediments, the total is around 1,600 million tons per year. So this account to about 8% of global discharge. So with this very large sediment discharge, actually is making the South China Sea as the largest sink of flow sediments among the enclosed and semi-enclosed ocean basin worldwide. So in addition, because South China Sea is a semi-enclosed basin, so all sediments from the rivers to enter the sea, and they stay in the sea and not go outside of the sea. So it's make it a natural laboratory to track how the sediments from the south and then in the sea. So then the South China Sea provide actually the excellent case for South Sink study among all the marginal seas. So today I'm going to talk about these 4 aspects. The first way I'll give very briefly the background of the South China Sea. Then from 3 aspects, the surface sediments, then the marine observation, and the perspective. So the talk today, the mainly focus the present time or nearby or approximately present time processes from the south to sink. So firstly, we look background, of course, because we work on the sediments. Most of the sediments come from the land, from the rocks. So we look briefly the geology surrounding the South China Sea. As you see, this is a geological map. So we can see the major features of the rocks and tectonics and climate surrounding the South China Sea. The firstly, so in the northern part, the South China and the southern parts of Malay Peninsula, so they are quite stable since the early of Mesozoic, and they are stable and mainly consist of granite and also, of course, sedimentary rocks. And in the South China, it affected mainly by the monsoon and subtropical climate, but in the Malay Peninsula is a tropical climate. So they are more or less similar geological and climate background. But however, also in north and south, in north, the Taiwan is very different because it's active, uplifted, and mainly sedimentary metamorphic rocks is different from the South China. And the climate is similar, the monsoon and subtropical climate. However, in southern part, the Borneo, especially northern Borneo, is also tectonic activity, and it consists mainly is sedimentary rocks, and of course, it's tropical climate. So these 2 areas is tectonic activities. And then we have other 3, the Indochina. So it's more or less stable, but it's still uplift sometimes because it is related to the Tibetan plateau. And in the Cenozoic, late Cenozoic, the volcanism is very active, was active. And also in this east part, the Luzon is mainly is volcanic active, and it consists of basalts. And similarly, in southern parts, the Sumatra of the west part of Indonesia is also consists of basalt. So they are similar to, in terms of rocks, is similar to the noodle. So this is geology because they provide all the sediments, or then the sediments transport to the South China Sea. So let's look at the monsoon, the climate and the current system. Because the South China Sea is a typical area of we call East Asian monsoon, because we have the Asian monsoon consists of East Asian monsoon and South Asian monsoon. So the wind is a reservoir. However, the current system is not always a reservoir. And in the most northern part here and the southern part, the current system is a reservoir in the summer and the winter. But however, in the middle of South China Sea, they are not really reservoir, and they keep all the same effect by the corrosion intrusion. So this is a surface current, but the deep sea current is more or less stable and along either the north slope, either by the deep current along the basin boundary. So because we know a little, actually not much, the current system in South China Sea, but because they are the major mechanism to transport sediments, as soon as the sediments discharge from the river to the sea. And in addition, because South China Sea is of course, is surrounded by many countries, China, and 10 Southeast Asia countries, including Myanmar and Laos. But even they are not really labeled the South China Sea, but they are the major part, one of the major part of the river system of Mekong. So they still produce sediments through Mekong then to the South China Sea. So this is the background. The second part, I will talk about the surface sediments. So why I talk about the surface sediments? I give the story. About 20 years ago, when I wrote the first the paper about clay minerals South China Sea, this is my beginning of the career in South China Sea. So it's about the past 2 millions clay mineralogy. This is actually the first the paper, international paper by the geological time scale. So actually it's quite a good cited, so more than 250 times. But even so, during that time, I interpret the sediments come from, the clay come from either the northern part or either the southern part transported by the surface current. But from time of view, during that time, we don't know where the sediment come from. And actually, we don't know all the rivers surround South China Sea, what kind of sediments or clay minerals they provide, because we have a very, very few knowledge. During that time, I read the literature to get the sediments approximately from the rocks, just to assume what kind of rocks can produce what kind of mineral. Of course, this is not exactly sure. And after 20 years, we know most of it is not correct. So I think 80% the knowledge is not correct. But during that time, it's still published. So 20 years ago, when I finished this study, I think we don't know the sediments, so how to analyze the provenance. So why do I to sample analysis by myself? So this is the intention of my study for the surface sediments. So since that time, 2003, the year of publish of the paper, so I start to the sampling surrounding the South China Sea. You can see over the more than 10 years, I go through all the rivers. And all the rivers, I do myself, the sampling by myself, of course, with the colleagues and my students. So this is a wonderful, I think, the wonderful work, and then it's supported by the Westpac project. It's called Intergovernmental Oceanographic Commission of subcommission for the RESPEC. So sediment, the project is called Sediment South China Sea Fluvial Sediments. So this project started from 2008 and will be continued to about 15 years. So every 2 or 3 years, we renew one. So all the scientists and colleagues from South China Sea join this project to make the possibility of the field work like here. So with this, the work, I collect all the rivers sediments and also some of them the coastal or shelf sediments, and also obtain or sampling by international cooperation to collect all the sediments in the deep sea. So here is just to present the surface sediments in the sea and also rivers. So all the surface sediments is real surface, is from the surface 1 or 2 centimeter by the core or box core. It's not the grab. The grab can mix the samples. So then you can see almost totally 1,500 samples, more than 300 samples from the rivers, and then 1,200 samples from the deep sea. So this make the mapping of the possibility of the mapping of the clay mineral. Of course, they have other heterogeneous sediments from all this work. So I show the clays because clay is quite interesting. Why I say clay? Because clay is produced by weathering, and most of deep sea sediments consist of a majority of the clay minerals. So we can see the clay minerals surrounding South China Sea are very different. It's quite complex also for my knowledge. When I did for the first study in 2003, we can see in the northern part in Taiwan provide all ignite chloride, almost 100%. There was no ignite smeltite. However, the South China provide almost 50% of galinite. So this knowledge is very different from the knowledge I referred during that time, 2003. During that time, 2003 is almost only the ignite chloride. It's similar to Taiwan, but they are completely different. And in southern part, we can see the Malay Peninsula and Sumatra provide a majority of galinite. Even the rocks, the geology is very different. Malay Peninsula it consists of granite. However, Sumatra is basalt, but they are still provide the majority of galinite. But if you see the Luzon, they have a similar rocks than the Sumatra, but Luzon provide almost 90% smeltite. So they are not, the rocks are the same, but they provide very different clay mineral percentage. And in the Indochina, with the 2 major river systems, Red River and Mekong River, they are almost similar, but middle Vietnam are very different. And of course, the talent is different. And in the Borneo, the southern part, we can find the northern Borneo is more or less similar to Taiwan. Even their rocks are different, but they have shared similar active tectonics. But in the western part of the Borneo, they are different. They are similar to the Malay Peninsula. And if we plot them together to see they have some regular or the similar feature. So I group them with the ignite chloride together, and then to plot them in tripod. The plot, the ignite chloride and galinite smeltite. So we can see all the area with relatively tectonic activities. So they are more close to ignite chloride and member. And with a more stable, tectonic stable, either not depending on the climate or the rocks, they are close to the gaulonite end member. And if the volcanism activities, so they are close to the cementite end member. So with this implication of the clay minerals, and of course it is related to the background of geology. So we obtain that the mechanism to force the production of clay mineral through chemical weathering, we think the climate is a major part of the mechanism, because either the rocks or tectonics, if the climate its effect is strong enough, so all the rocks actually will be weathered to the gaulonite. But however, if for some of activities, the tectonic activities, so they are still keep the inert chloride. It's like the bunion here. Or however, if the volcanical activity is too strong, and they are the close to the cementite end members. But however, if the climate is stronger enough, they are still to shift to end member of gaulonite. It's like Sumatra is still here, meaning, so we can see that a little different climate. Sumatra is a real tropical, close to equator. However, Luzon is close to the subtropical, so climate is different. So make it a very different end member of the weathering. But this is the clay mineral. If we look at the major elements, I process all the samples of river samples in the bump and also in the clay size. So they produce exactly the same weathering trends as the clay minerals. So here we can see the lynch processes of the calcium, the sodium and potassium. So I will not go to this the map of details. So I just the number of the from 1 by the area, the major area from 1 to 9 with the increasing of the chemical weathering. So actually, the Luzon is shared only the intermediate chemical weathering. So in terms of chemical weathering, compare all the other areas, the Luzon is the weakest. Then we can find it Taiwan, and then the Red River, and Mekong, and Northern Borneo. So then we can find the more chemical weather, like South China, and Thailand, and then Peninsula and Sumatra. So Sumatra is shared the strongest the chemical weathering. So with this study, so we can understand the controlling factor of the production of the clay minerals from all the rivers from South China Sea. So chemical weathering through the climate forcing is a major mechanism. Then is the tectonics and the nosology. So this is the rivers. When the rivers, most of the river sediments go to the South China Sea. So we map the distribution of clay in the South China Sea. So we can find they are very different in terms of different minerals. So you can see the cementite, inert, gaulonite, and chloride. And the major feature is similar. It's inert and chloride are very similar. So we plot them. We can see in the South China Sea, sea floor surface sediments, they are almost linear. So if we plot all the rivers surrounding the South China Sea, they are more or less linearly. It's still very good correlations. So meaning within the sea, the inert and chloride share the same provenance. So with the increasing of the inert and chloride also increased. But however, if we see a cementite and gaulonite, they're very different. So from this mapping, we can see the provenance, like you can see the contribution inert chloride from the Taiwan, and also the contribution of the cementite from the Luzon. is a major the reason. And then we can find alkalinite. So alkalinite is distributed only in the coastal area. Few of them, the real few of them can enter the sea. So in the northern part, in the deep sea, usually is less than 4% or 3%. In the southern part of them, it's just 10 or 20%. However, we know in southern part, the Malay Peninsula, almost 90% of alkalinite. By Sumatra, it's 60%. But why the sediments of the alkalinite couldn't get into the sea? Because they are just deposited around the coastal area. So this is what we call the differential settling. So from the distribution, generally, we can get the knowledge that the provenance from the river and the differential settling, their behavior in the sea is major controlling factors. But however, if we compare the distribution to the current system within the sea, so we can find the smalectite, inert chloride. So the background is the mapping of the surface sediments. So we plot them with overlap the surface current here during the winter and summer, and also including the deep sea current. It's quite good correlated, to meaning that the surface current is the major mechanism to transport sediments from northern part to the southern part, and especially in the most of the southern South China Sea. And also deep sea sediments, the current and bottom current can transport the inert chloride into the sea. So if we see the northern part is we have more data distributions. We can see like the inert chloride, they are transported by two mechanisms. One is the coastal current during the winter time, and also the bottom current, current during the outer time of the year. We can see the tone fugue distribution along the coast, the continental shelf, and also from the continental slope, and also to the deep sea, could be a bottom current or tributary current. And if we see the smalectite, the majority of smalectite is distributed around the Luzon, but they are just limited in the Luzon, and then a little to the west of the center South China Sea, because we have the deep current. So meaning the deep current, so it's constrain the further west transport of the smalectite. But in other words, smalectite can be transported by the surface current to the westward. So they can cross the deep sea. So you can see northeastern part, the deep sea. In the deep sea, the smalectite contribution is still low. But under continental shelf, outer shelf, and upper slope, the smalectite is increased. So meaning the transport by the surface current. So this is the interpretation of the distribution of the surface sediments of the deep sea. So here I give a brief summary for the first part, the surface sediments. So we can get the East Asia climate, the climate through chemical weathering, that dominate the final production of the river sediments, while tectonic activities and specific meanings of volcanical lithology are the secondary of factors, affect mainly the initial stage of the sediment formation. And second is the province, ocean current, and different settling, they all control the South Sea transport process in South China Sea in terms of surface sediments. I mean, it's close to the present time. It's not real present time, because the surface sediment can be years, 100 years of the accumulation of mixture. So this is the first part. However, when we actually we publish this all the studies, and so with this paper, actually the citation is quite higher, more than 200. Since the year of publication, this paper is standing always for 5 years to the top 10, top 1% of the paper. But we still cannot to answer the remaining questions. How do sediments transfer at present time? As I said, the surface sediments is not real present time. So how do the transport respond to dynamic processes? So we still don't know. We correlated the surface sediment to the current system, but it's just correlations. So it's not possible to use the surface sediments to get the transport. So this questions is forcing me to consider to do the observation. So in about 10 years ago, I start to do the observation. So surface sediments 20 years ago, then 10 years ago, we can see we have a lot of studies for the mooring systems through the South China Sea. So the third part, I introduced our mooring observation, mainly in the deep sea aspect. So you can see all the moorings are located in the deep sea of South China Sea. So with the financial support of the deep sea, South China Sea deep sea program, we established the more than 10 mooring systems, use like sediment traps, ADCP, and RCM, CD, many dynamic processing, and also for the sediment connection studies. So firstly, this is a cooperation with the Bremen University. So they actually deployed in the past 20 years for the 8 sediment trap stations. Here you can see we have 2 transects. So with all these stations, they combine them together. So here is the up trap, so around 500 meters, and then the deeper trap around 2,000 meters. You can see the flux of clay minerals almost double or treble in the deep sea. It's not on the upper surface. So meaning most of the clay minerals is transported by the natural transport by the deep current instead of a vertical deposit. So if we plot them all the traps, so this one is a group of different traps, and with the different trap depths from each station, we can see from the up to the deeper trap, the flux, the red one symmetrize is increased. And if we to compare the 2 transects, is more easily to see, like transect AA and BB here. So we can see most of the sediments either come from the northern part. Here's the northern part, and then the southern part. They transport by the surface current system or subsurface by the balloon. And however, in the deep sea, close to the canal shelf or slope, they can transport either by deep current or either by lateral layers. But however, in the central part of the South China Sea, so they are accumulated by the semaglutite, mainly by semaglutite. So meaning semaglutite is a very special minerals. So they keep it in the water for a long time, and this is the result the accumulation of a higher flux of semaglutite. So this is a general review. But however, this is the only sediment trap studies. So how the currents transport them. So within the work, because we have more data background in the northeast part. So then, in order to understand how the sediments transport in this northeastern part. So we established the net of the mooring systems. So you can see with this small color, we deployed 12 mooring systems. So to determine if the current transport sediments are vertical or by the surface. So these systems already exist to work for 10 years. So they maintain by annually, every year we maintain, recover, and redeploy them. So we have some study results already. So firstly, we can see the digital line is a 2,000 meter water depth. So you should understand the basin wide how the deep current transport sediments. So we observed this called countercurrent systems. So countercurrent systems is always most of the time in like the blue color transport along the lower continental slope to the westward. So at this site is accumulate the sediment drift here, and the current system actually is like a tunnel site. It's a velocity structure. So at the bottom is a low velocity and then increased, and then is by the bottom boundary layers usually is 100, 100, 200 meters or hundreds of meters, and there has seasonal variations. So you can see the most of this is a major pattern for summer and autumn, and with this transport of the current systems, we transport the sediments. So here is the reconstruction of the sediments, the turbidity, and we can find this is the mechanism of the transfer by the countercurrents. Actually, later on, we have another study to show that the countercurrents is a major mechanism of transport sediments. In the northern part, annually is transported around 80 million tons of sediments. It's around probably half of the sediments discharged from Taiwan, meaning almost half of the sediments is transported by the current from Taiwan. Another half probably is transported by the turbidity current and to the deep sea. But however, the countercurrents in principle is transported to the westward. But we can see not always the blue color here. The red color is the current is reversed. So this is the medial scale eddies. So when the eddies start from the neutral, then move westward, like red here is our mooring systems. So here there are two eddies. So we also to estimate the eddies. So each eddy to move probably move to few months to westward, and is transported about half chance of the sediments. So this is the two eddies. We estimate is around 1 million tons of the sediments. So eddies is wonderful the mechanism. But the amount of sediments is not like the huge like countercurrents. And however, we are looking at another major dynamic processes is the turbidity current. So we have a array of the moorings along the Gulping Canyon. So here is a wonderful result from we call it G. Another one is at water depth 2,000, a little more than 2,100 meter water depth. So we keep them for the years. And here presents almost 4 years of mooring the system time series. So we can see each time when the typhoon to across Taiwan, so increase the discharge of a sediment and water and the sediments. So the sediments to discharge, to transport along the the Copping Canyon, then produce the turbulent currents to reach the mooring sites. So each typhoon, after typhoon, is like around 1 week, a few, 2 or 3 or 4 days, the sediments bloom will come to the lower part of the canyon. So you can see the sediment trap, the bottle is full. Then the turbidity, the concentration of the sediments is increased, and the currents increase a little. So with this work, we actually can understand in this canyon system, most of the turbidity currents is forced by the typhoon instead of the earthquake. So in all 4 years, only one earthquake occurred, but this earthquake also produced the turbidity currents. But in overall, most of currents by the turbidity current by the typhoon. So with this work, actually we can predict the currents in the lower canyon, the turbidity current by the typhoon. Another work. So actually, the heterogeneous sediments input at the same time they transport the organic carbons. We find that the organic carbon transported by Taiwan and by Luzon, they are very different the organic carbon, and also they are different association of the clay minerals. The Luzon provides smeltite associated with the soil, the panogenic organic matter. However, the Taiwan provides E9 chloride associated with the protonic organic carbon. So although the N2C, the panogenic organic carbon is lost, is replaced by the ocean salt, the marine organic carbon. But however, the protonic organic carbon stay associated with the E9, they keep within E9. So this is actually effect with the deep sea carbon cycles. So this is wonderful the work actually this is the first time to obtain the heterogeneous organic carbon actually is transport and decided by the clay minerals, because the different clay minerals associated affect different organic carbon. So I give the third summary here by the observation of deep sea, only deep sea. So deep sea dynamic processes and also events at various spatial temporal scales actually dominate the settling and later transport of particle sediments. However, we still have some problem with the further works, because we still don't know how are sediments transported from the estuary to the deep sea, and the controlling factors at the present time scale, present real time. So here I give you some perspective. Is the work I wanted to do, or just start, probably for next 10 years, for the real time observation and the flow of sediments inputs. So the strategy, the intention is to deploy the systems from the estuary. You can see they have some different estuary. We put the yellow one as a priority, and the white one will be the second stage. And to monitor it and qualitatively to assess the effect of the sediment transport related to the extreme or events of climatic events. So the plan is to deploy the 4 systems at the first stage. The one is we call the Mekong transect, to deploy the systems at the Mekong estuary and also the deep sea by the moorings, to see like what large river South Sea systems. The second is to deploy from the Sumatra small rivers, but with a very wide canal shelf, to see this kind of South Sea systems. And also the third in the northern Borneo, at the Ranger in Malaysia, the transect, to see mountainous rivers, south to sink systems. So with these three systems, we share one major deep sea mooring system, but with the different, very different end member of the estuary systems. And in northern part, we deploy, of course, the Luzon, because it provides symmetry. It's very rich with organic matter transit. We call it Cagayan transit in northern Philippines. So this is ambition, actually, the work. But we are, I'm not kidding, but we still already start to do it since last year. With the last 2 years, we firstly deployed the mooring system in southern part. It's already maintained for 2 years. We have a preliminary data for this one already. But however, we plan to start at the Mekong estuary to deploy the observation systems. It's called real bottom node observation systems. But because of the COVID-19 pandemic effect, so we postponed this study because it's not possible to do the international travel within the last 2 years. Hopefully, in next year, we will deploy. Then we can complete the first transit, and then to the Sumatra and northern Borneo to complete the priority study in the southern part of South China Sea. This is the intention of the work of the South Sink to see the real time from estuary to deep sea. So this is my auto talk. So thank you to all the colleagues and the institutions, and thank you for all of you to attend my talk. So I'm waiting for your questions.
Thank you, Zhifei. This is excellent talk. I have learned a lot from your talk. Any questions? Now we open the floor. You can unmute yourself and go ahead and ask a question. You can also type the question in the chat box.
Hey, Zhifei, that's yeah, really amazing. You know, I'm pretty familiar, you know, your earlier work, as you mentioned, but I didn't realize in the last 20 years. Gosh, that's really amazing. So much work, fantastic data, and also help us understand very well the climate, you know, the clay mineral, and also the dynamic. I have a question. The current from Taiwan, the transport, you think a majority is from the near the river mouth, from the Goping or near shore Taiwan, or there's some resuspension, the previous deposit sediment, then transport, or for example, the erosion of the slope, the shelf break, then transport. So,
thank you, Paul. It's a very good question. So actually, it's mainly concurrent. It's driven mainly by the deep current from the Western Pacific to enter the Luzon Strait. So at around 2,000 meters water depth, then just they pass by the Goping canyon. So it could be transport by bus pipe transportation of the sediment from the Taiwan to the westwards. So they are not start from the shallow area. So meaning the sediment is transported by the rivers and then by the canyon to the deep sea, and there is suspension, and then the deep current just by the pipe to transport them. So meaning most of them just a cut of transport, and instead of all the sediment go to the deep sea, they transport by the current systems.
So have you done any carbon analysis? It show a modern, mainly the modern carbon, or there's some old carbon?
Yeah, from the Taiwan, mainly is the old carbon. It's a very old. You can see the Taiwan is here, the carbon is here. So it's FM is like 0.005. It's around like 10 or 20 kilo years the age, or even older. So here's the older carbon from Taiwan is here. But however, the carbon from Luzon is very young. It's mainly from soil, like 10,000, 10 or 1,000 or 2,000 years. But Taiwan is 10, 20, or even 40, even older than the C14 dating age.
Oh, okay, good. So last question, can you go back to the last slide, show your future plan? 31 maybe, yes. This one or last, yeah, this one. This is really ambitious. This is fantastic. And nowhere in the world, no institute can do this except China, Tongji. I mean, that's just
okay. Thank you.
That's very good. But I have a suggestion. Why not you put one between the central Vietnam and the Hainan Island? Because this is also an unknown transport from Gulf of Tonkin to the out. And second one is from the Pearl River mouth, go all the way to the Dongsha. That's other interesting transact.
Yes, a good idea. I put some start here. I did not put it in a priority. The first step. The reason is I think they have similar, not exactly the work like this study, but they have some observation. The other colleagues in the river mouth of the Pearl River, and but they did not go see. I think I choose the southern part because there are almost nothing work to do here.
Yeah. Okay.
And could be more interesting, and just to compare the one in the northern part.
Very good.
I think the work I hope to cover it with you in the future to do this work.
Well, yeah, I need to write more proposal to catch up you guys, and so okay, thank you.
Okay, thank you.
Any other questions?
Yeah, I have.
Hello.
Yeah, this
Hello.
is Mount Misha from NC State. I'm working with Professor Polu, and I may be a bit specific. I was studying deposits in Northwest Borneo, and there was in some areas, in the very northwest areas, about more than 20 meters of shale sediments. So I just want to know your recommendation, or your if you have any idea. I was trying to find out the source of these sediments, of these shale sediments, and a lot of clay minerals, especially chlorite and illite. Was it sufficient to correlate the XRD and SEM data to say that the source of those sediments is from, for example, the Northwest Borneo rivers like Baram River? I'm just want to know if that was right, or yeah. And of course, thank you for the presentation. Very good presentation.
Okay, I think it's a good idea. You see, I didn't have much samples in the offshore of northern Borneo here, only a few of them. I think to measure your samples with for the clay mineral or the measure elements is good. It's very good. So to compare the study, I have already done. So if we have interest, we can do it together, or I can to provide the analysis for you for free. So you can use the data to compare the earlier data. I think the most resources here come from northern Borneo, from Raja and the river here.
Yeah,
so,
yeah.
They're good.
Okay, that's great. Thanks again for the presentation, and thank you for. I will of course contact you to see how we can do anything together. Thank you.
Yeah, you can write me email or send the samples during this time. It's not allowed to traveling.
Thank you.
Any other questions? Can I ask one, Zhifei?
Yeah, please, Kevin.
So you showed some really interesting sediment concentration data. So during some events, the sediment concentration increased to a few milligram per liter. And if you compare that concentration with the concentration of lots of rivers, such as Taiwanese rivers or Pearl River, most of those large rivers have a concentration close to a few hundreds of milligram per liter. So did you use the ADCP backscatter to calculate the concentration? That concentration seems to be a little bit low, but this is also in a deeper environment. I normally deal with shallow water continental shelf. I deal with concentration a little bit higher than a few milligram per liter.
Yes, you are right. Because for the moment, for the observation, is like this one. Is concentration reconstruction from the ADCP. They are quite low because they are deep sea at this one station at about 2,000 meters or depth. So it's compare the concentration in the river system or the continental shelf is quite low. So I did not to do the observation on the shelf or estuary. So this is my future work to do.
Okay.
So yeah, I think that we are using this parameters reconstructed by the ADCP backscatter data.
Yeah. Have you tried OBS, optical backscatter, to collect the sediment concentration?
Yeah, for the moment, not yet. For the moment, not yet.
Okay.
Yeah, for the DBC, OBS is good. It's very good. We did a little by the cruise, but just cruise time is not on the mooring for the long-term scale, just by the casing from the ship using the using OBS. So it's associated with the CDD casing. It's just a few side for a few transects, but not on the mooring systems.
Okay, thank you. Any other questions from the audience? No questions? Finally, I want to compliment Dr. Zhifei Liu. He collected sediment samples from 180 rivers. That's tremendous amount of effort. It makes me jealous because we all study rivers, we study deltas, but our field data collection are very, very limited. Collecting samples from 180 rivers is a tremendous amount of effort. I want to compliment Dr. Zhifei Liu about your effort. Okay.
Thank you.
Okay, any other questions? Okay, just a quick reminder, next week we will have another talk. Remember, it will be 9 a.m. Eastern US time. It will be 10 p.m. Beijing time. Okay, so it will be a different. Thank you, guys. Bye.
Thank you, Zhifei. That's great.
Thank you, Kevin. Thank you, Paul, and thank you, everyone.